Our warm-up for today is to determine if this point P lies on this line here, okay, defined by this vector equation. So pause the video, see if you can figure it out. If you're not sure what to do, then certainly continue on and write it down as an example. But pause the video, try it on, and then come back to the video to check your answer. Okay, so basically we're going to see if this point satisfies this line. So we're given the x, y, and z coordinates for a point. We're going to plug it in and see if it satisfies this line. Note that we can kind of have any t that we want. So we're actually going to figure out if we have a t that will allow us to have this point on this line. So first I'm going to recognize that x is equal to -2 plus 3t. Okay, and if I plug in 7 for x, I get -2 plus 3t. So 9 is equal to 3t. So t is equal to 3. So for 7 to be the x value, our t must be 3. So what we're going to do now is check if that t at 3 works and gives us a y value of 10 and a z value of 2. Okay, or we can do a simple left side, right side check. So that's what we're going to do. We're going to recognize that y is set up equal to 4 plus 2t, and my left side, the y value is 10. My right side, I'm going to have 4 plus 2, and for t, I'm going to have 3. So I get 4 plus 6, which is equal to 10. Left side equals right side, so that t value satisfies that y equation that we set up. Similarly, I mean, you could solve for the t for x, y, and z. That's fine too. This is probably just a little bit quicker. So z is equal to 5 minus t. And so my left side z value would be 2. My right side would be 5 minus 3, which is 2. So therefore, 7, 10, 2 is on the line. And it's on the line when our t value is equal to 3. Okay, so when we're separating the vector equation like this for each variable, we're actually using their parametric equations of the line. So, and what I mean by separating, I mean we had an equation for the x, the y, and the z, okay? So let's start by reminding ourselves that we have a vector equation here. So this is we consider this like the geometric vector equation. So geometric vector equation. And this can be written as xy is equal to x naught, y naught, so that's just a point, plus t, m1, m2, that's our direction vector, right? And this one here is our algebraic vector equation. Okay, so we have those two. So what we're going to do is just rewrite our algebraic vector equation as parametric equations. Okay, so all we're doing is splitting up that x and that y into its own equation. So we would have x is equal to x naught plus t times m1, and y is equal to y naught plus t times m2. So all I'm doing is recognizing that x is equal to this plus this, and y is equal to this plus t times m2, okay? And these are our parametric equations. In 2 dimensions, okay? Now we can also write parametric equations in 3 dimensions, so to have that, it would be the same. X is equal to x naught plus t times m1, y is equal to y naught plus t times m2, and z is equal to z naught plus t times m3, okay? And these are our parametric equations in R3. Okay, and basically all we're doing is kind of using what we did in our warm up, right? Um, we're splitting this equation into its pieces for x, y, and z. Okay. Okay, so let's take a look at some examples. So this one's pretty straightforward. Determine the parametric equation of the line given by r is equal to 3, 2 plus t negative 1, 2. Okay, so basically, again, we just split up those x and, well, in this case, just x and y. So my parametric equations would be x is equal to 3 minus 1t, so just 3 minus t, and y is equal to 2 plus 2t. My next example is going in the other direction. We're going to determine the vector equation of a line given the parametric equation of a line. Okay, so I'm going to I'm just going to use R. You could, if you wanted to, write XY like that. You can write your vector either way. It doesn't matter to me. And then we know that that first vector is our position vector. So in this case, it's going to be 7, negative 2, that's our x and our y, plus t, and then our direction vector, which is for negative 3. And again, this would just be the same. Either way is fine with me, however you want to write it. Okay, so now let's explore, you know, questions that maybe just aren't as straightforward. So this one asks us to determine the parametric equation of a line. So we know that we're going to be writing out x equals, y equals, z equals, passing through these points, okay? So the things that we need to find for our parametric equation of a line, I want you to remember, is that we need to find basically that direction vector and a point, okay? Or so that we can make R naught, okay, that position vector. So those are the two things that we need. So let's go ahead and find our direction vector by taking those 2 points and finding vector PQ. So that's just going to be equal to, so negative 2 minus 1, negative 3, and then negative 10, and then 1. So there's our direction vector. And then we know that we can use any point on that line as our R naught. So my R naught, or my position vector, I'm just going to use P as my endpoint, but you could use Q as your endpoint. It doesn't matter. So I can write out now my vector equation. Okay, so I can write out, so 1, 4, negative 1 plus t negative, negative 3, negative 10, 1. And then from that, it's really easy to see my parametric equation of that line. So I have x is equal to, so therefore x is equal to 1 minus 3t, y is equal to 4 minus 10t, and z is equal to negative 1 plus t. And this is our parametric equation. Okay. Okay. So before we move on to our next examples, I want to remind you about a scalar equation of a line. So a scalar equation of a line, which probably was introduced in grade 9, is ax plus by plus c is equal to 0. So note that a, b, and c are not fractions. Okay. And this equation here is only in 2 dimensions as well, okay? This scalar equation of a line. So let's move on to our next example. Okay, so here we are at example 3. We're going to find the scalar equations of the following lines. So this first one looks very much like an equation of a line that you would have had in grade 9. We can just, first of all, we want to not have any fractions. So I'm going to go ahead and multiply this whole equation by 3. Really, we should have multiply both sides, but that's okay. So I get 3y is equal to 2x plus 18. Okay. And then I'm going to move everything around so that I have my x, my y, and my constant equal to 0. So I'm going to have negative 2x plus 3y minus 18 is equal to 0. That's our scalar equation. Now, usually, like for good form, we don't like to have a negative leading coefficient. So you might see questions like this in the back of the book, the answers. Where we multiply both sides by -1, so that leading coefficient is positive. I'm fine with either one for your scalar equation, so it's up to you. Okay, let's take a look at the next question. So we're finding a scalar equation for this question. So the things that we need to set up the scalar equation are our slope and our y-intercept, right? And that would give us basically an example like the previous one that we have. So if I want to find my slope and y-intercept, I'm going to think about this a little bit. Um, let's think about our direction vector for a minute, okay? If I were to think about that direction vector for a minute, okay, -3 and 2, and I put a point here, and I position it, with the tail at the origin, this is where we can find our slope. Okay, so when I take a look at that line with that direction vector, I can see that the slope, remember, is equal to rise over run. So my rise here is 2 and my run is -3. So my slope for this line with this direction vector is actually 2 over -3. So we can actually find the slope with that direction vector. So maybe make a little note here. So my direction vector for this one was -3, 2. And whatever your direction vector is, this is always going to be the rise, and this is always going to be the run. And if that confuses you a little bit, just take a look at how it relates in our diagram, and you can see that slope and how that comes to be. Okay, so we know our slope, and then we also know a point. So we know a point on the line. It might not be the y-intercept, but we know a point on the line is 2, 1. So I can certainly find a y-intercept. So I'm going to use those two things to help me start. So I'm going to have y is equal to -2 over 3x plus b. I'm going to plug in the point 2, 1. So if y is equal to -2 over 3 times 2 plus b, and so I have 1 is equal to -4 over 3 plus b. So 1 plus 4 over 3 is equal to b. So I'm going to have 7 over 3 is equal to b. So now I have the line y is equal to -2 over 3x plus 7 over 3. And now all I need to do is make it that scalar equation. So the first thing I'm going to do is multiply the whole equation by 3. So I get 3y is equal to -2x plus 7, and I'm going to rearrange and set it equal to 0. So I have 2x, so this is my final answer here. So therefore 2x plus 3y minus 7 is equal to 0, and there's my scalar equation. Okay. So I just wanted us to take note of, again, finding slope from a direction vector, because this is going to come in handy for many questions. So a direction vector for a line with slope, let's say b over a, is the direction vector AB. So again, in this direction vector, this would be our rise, and this is our run. Okay? Okay, so next question, same question. We want to find a scalar equation of a line. So we're given here the parametric equation. We know that we can rewrite this as a vector equation. So I have -4, 1 plus t, 8, -1. Great. And from this, I know I can find my slope. So -1/8. And I also have a point, okay, which is -4, 1. And so basically, I'm going to follow the same steps that I did in example B, where I would start with my equation and that slope, and I would go through to solve my y-intercept and then convert it to a scalar equation. So I'm actually going to leave this one. We've set it up. It's basically the same example as example B. You're welcome to try it. So your answer, your final answer for your scalar equation, I'll put it here for those of you that are going to pause the video and give it a try, is this here. Okay. So this is our last example. We're going to write a vector equation for the line that's given here, and this is a scalar equation. So I'm hoping that you're recognizing that we need to know the names and what the names of different types of equations and what they look like, especially because we need to know what form we're looking for, what form that question is asking. So it's asking for a vector equation. So I want you to think about what we need for a vector equation. We need that position vector and we need that direction vector to make a vector equation. So I can get the direction vector from the slope. So taking a look at this equation, I'm going to rearrange this into slope y-intercept form. So I have -y is equal to -3x minus 8. Y is equal to 3x plus 8. So my slope is equal to 3/1. And remember, so this is our rise and this is our run. So from that, I can get my direction vector, which is 1, 3. The only other thing I need is a point on the line. Well, I have a point. I have my y-intercept. So my y-intercept for this equation is 0, 8. So I can use that for my position vector. So my final answer here is the vector equation. Again, you can write r or you can do x, y, it doesn't matter to me, is equal to 0, 8 plus t, 1, 3. And that's it for today's lesson.